So my name is Spencer Crum. I work at IBM. I work on Openstack. In terms of open source contributions, I mostly contribute to Openstack. I'm also involved in public communities, a couple other smaller contributions here and there. I'm paid to work on Openstack. I'm paid by IBM to work on Openstack. IBM is a big Openstack competitor. I'm going to try to keep this pretty neutral. There's a reason this isn't the IBM approved slide deck format, right? This is just kind of a community talk that I happen to work at IBM for. I want to be really clear that I submitted this proposal really more ambitious than I should have. And I didn't really get the prep time I wanted to put into this talk. I thought this talk would be a lot easier to prepare for, and it was not. So if you're actually super interested in advanced topics, this might actually be a bit of a snoozer for you, because I didn't get very far. I had this bold ideas of setting up all these services and demoing them for you, and that didn't actually work out. But we're still going to talk about Openstack, especially if you're here and you're like, I'm interested in Openstack. And you don't have expert knowledge, you'll probably get a lot out of this talk as well. So yeah, the big goal is kind of demystify. I really don't want to give a vendor pitch. I'm going to try to be as honest as possible and clear. So this is Portland. I'm from Portland. Established most people are coming from the Pacific Northwest, it sounds like. But I travel all over, so I always put the Portland slide in. That's Mount Hood. Portland is not full of. It's not raining all the time in Portland. It's actually pretty nice. That's the OpenStack logo. Yeah, used with permission. It's Jimmy Fallon. All right, so our introduction is kind of, the agenda is kind of, we're going to introduce some stuff. We're going to go through some basics. And we're going to talk about vanilla, designate, Barbican, Magnum, LBAS. Actually, we're not going to talk about LBAS at all. Devstack, OpenStack debugging. And we'll finish up with ironic Bifrost. And there'll be a cute demo with my NUC. Yeah. All right, so who am I? I went to PSU, Portland State. Been a long time friend of a number of open source projects. We test. What I do for IBM is I don't really write OpenStack code. What I do is I run the OpenStack developer infrastructure. And so OpenStack's an open source code or open source project. So if you show up to OpenStack with a patch to make it better, or maybe worse, it goes through my code, the code review system that I run, and then the testing system that we run. And so at peak times, we'll push 20,000 tests through our system a day. And that's booting a virtual machine with 8 gigs of RAM, installing OpenStack on it, and running a suite of acceptance tests called Tempest, which kind of whittles at the APIs and tries to break it. Internally at IBM, I help them deploy cloud. This is the OpenStack mission statement. It says to produce an ubiquitous open source computing platform that is easy to use, simple to implement, interoperable between deployments, that works well at all scales and meets the needs of users and operators of both public and private clouds. It's gotten mended a couple times, but the idea there is that we're going to be open source and it's going to be simple to implement, and we definitely are open source. So there's some basic things you can ask an OpenStack to do. Right, you can ask it to make a virtual machine, you can ask it to destroy a virtual machine, you can ask it to set a DNS record, you can ask it to just hold onto a file for you, you can ask it to give that file back, you can ask it to make a database or a disk. A lot of people say, Spencer, I can't OpenStack, it doesn't work for me. And I'm like, that happens. So Devstack. So how many people have run Devstack here? Four-ish, five-ish? Well, today we will all run it. We will pray to the demo gods, and we will run Devstack, I think. Oh yeah, that'd be great. Okay, so running Devstack. So Devstack is actually just a shell script. It's a Git repo, but it's also a shell script that will bring up an OpenStack for you. This is the idea is that you would run Devstack after you write your changes. And so the simplest thing to do is to run create stackuser.sh, which creates. I kind of came up in an environment where we were root when we were doing administrative tasks, and then we were users when we were doing user tasks. And since then, everyone got really excited about using a user instead of root, which is fine. But then you give a passwordless sudo to this user, and I've never really understood that, but that's the standard way to do it. So we will we'll just go ahead and sudo the stack user. And then we'll clone get a Devstack some more. And then it's not really rocket science. You just /stack.sh, and it will likely ask me for some questions. Yeah, so it wants a database password. It wants more passwords, and I just set the passwords to the same things. And so we'll come back to that later. we'll let it Devstack for a little while. All right, so what are some less basic things you can ask your Openstack to do? Well, you can ask it to snapshot a VM for you. You can ask it to upload an image. You can upload a new disk image you made with Packer or Disk Image Builder or something. You can set up rules for scaling. You can host containers. We're going to talk about some of that stuff today. Ultimately, what it comes down to is Openstack is Python daemons. Like, that's the code that is in Openstack. That's what we write. There's like some work to make other languages there, but the important thing really is that what Openstack is not Openstack is not its own hypervisor, which I don't think is necessarily a misconception that this audience has. But a lot of people come to me, they're like, well, is it different than KVM? And it's like, no, it sits at a layer above KVM, sits above Zen, or something like that. It's a management layer written in Python. So Python is listening for REST endpoints. So ultimately, it's infrastructure as a service. So, and those are implemented with REST endpoints. So sometimes things that used to be in the data center that used to be a ticket, hey, can you make me a VM? Hey, I need some more storage, whatever. Often that is, the idea really is that you'll submit a request to a REST API instead of a ticket now. And then, of course, it's open source, which is not super complicated here. All right. I don't think we need to go through this. I think most people know that kind of stuff. I would like to harp on the four opens: open source, open design, open development, open community. This is kind of the core principle of OpenStack, because we don't want to be a inside baseball club that is a handful of vendors. We want to be an open source community that's building things correctly. And it's important for anybody who stands up and says, I would like to be involved in OpenStack, to feel like they can be involved in OpenStack. So all our conversations happen on IRC or mailing lists. There are in-person conversations that happen at 2 design summits. One of the design summits starts tomorrow. If you would like to go to one of those and you don't have the financial means to get there, there are lots of support. There's a big support program that makes it pretty easy for someone who doesn't have the financial means to make it out to the design summit. The next one is in Austin, Texas. And the one after that's in Barcelona. Okay, so it started in 2010, Rackspace and NASA. Matak is out. Newton Summit starts tomorrow. I just pulled this. So about 600 Git repos, 7,000 emails every 6 months. That's actually lower than the real number, but 20K commits every 6 months, and 100,000 reviews every 6 months. We have a strong culture of reviewing code instead of just throwing it over the wall. All right, so the standard OpenStack services. Nova is your kind of wrapper around compute. They would call that OpenStack Compute. It's your wrapper around KVM or VMware or Zen. Neutron is your wrapper around pick your favorite software-defined networking. Most people use Open vSwitch. Some people are starting to use OVN, which is in Open vSwitch. And then people that have like work to do often use Linux Bridge, because it just kind of is like, yep, I would like the networking to work. There's a great talk from the Tokyo Design Summit that's like, I can't ping my VM, what do I do? That's like the topic. How do you debug that your VM doesn't ping? And as we'll see later, my VM doesn't ping. So Glance is like the simplest service. Basically, if you have an AMI or a Packer image or something, you would like to boot a virtual machine for, Glance will store that for you. Cinder attaches, it's Cinder block. So it's the block storage. So you could take it, if you were doing attach a 2 terabyte disk, you're going through Cinder. Keystone sits roughly where my IAM does. It's the authentication, quotaing, that kind of stuff. So you could say I'm a user and I have these credentials and I have this much quota and such. Swift is an object store. It's a blob store. Trove is database as a service, designated as DNS as a service. All right, so this is kind of what the web UI looks like. It's not really important. This is really how most people interact with OpenStack. Is they zoom in too much? I don't know if you guys can see that, but basically you just have environment variables that let your shell, the programs that you run on the shell, know where where your OpenStack is and your username and your tenants and stuff like that. I have a lot of these GIFs. It doesn't. I guess we'll do list machine. List machine is fine. So you run some kind of an OpenStack list command and you get out one of these grid things that everybody's been making for years. And you can destroy things. This is kind of your. How many people have not run at least one of these commands? Okay, so there's about a third of you that have not run an OpenStack command. Basically, what happened is they started out with Nova commands, and then they decided that they would, and like glance commands and keystone commands, all as unique. And then they decided to consolidate it all in the OpenStack utility so that it can have other stuff. Which is nice, because instead of Nova boot, you have OpenStack server create, and everything is create, instead of sometimes it's boot, and sometimes it's create, and sometimes it's whatever. This is an example of like creating a new disk. That was, see, there's some Nixos. We were uploading Nixos images to OpenStack because we didn't have something to do that night. So this is kind of how you would use Ansible to list your instances. It gets a little more advanced. So Ansible has dynamic inventory. OpenStack.py lives in Ansible's contrib directory. You just use it and let it know, and we'll get it done. And this is kind of the bizarre way you iterate in Ansible. Basically, it's a playbook, and like these things are pretty standard. They kind of configure what kind of VM we're going to make, and then we're going to make OS server, and then with items means for each foobar baz run OS server. It's kind of a map function. And so if you run this playbook, it'll look kind of like that, and it'll say we changed foobar baz, which means it created servers. And so when we run the list command, we can see we have we have 3 more machines in our inventory. There's a shade library that we're working on. This is kind of like a fog clouds.yaml file. Shade allows you to use Python to simply cloud.create server. And the reason we needed to build shade was because OpenStack is an abstraction in front of your infrastructure, but it has leaks. There's leaks in the abstraction that basically the exact choices that the operator that runs the cloud has made sometimes change how you need to use the API, and it's hard to discover how to use the API correctly. Like the classic example is you would like to boot a VM and you would like it to have networking, and sometimes that's a one-step process where you say boot VM, and sometimes it's a two-step process where you boot VM and then associate an IP address with it. And discovering which one you have to do is not currently available in OpenStack clouds. So what we did is, given that there are only about 20 public clouds, we simply have a file in Shade that knows, oh, you're using Rackspace? I know the pattern I have to follow for Rackspace. Oh, you're using VexHost? I know the pattern I have to follow for using VexHost. It's not perfect, but there's only a few patterns. So you just map one of 5 patterns onto whatever cloud you're using, and you're done. Okay, so further services, Manila, Designate, Barbican, Magnum, LBS, and ironic Bifrost. So I believe, Manila is the shared file system service for OpenStack. So the idea here is CIFS and NFS. So, and this totally did not work for me. Like I totally tried to run their Devstack and nothing happened. Let's actually check in on our Devstack. It's still going. It's Devstacking. So basically the idea is that you can boot a virtual machine or whatever, and then basically say, I would like to provision 2 terabytes of NFS storage with an exports list of blah, and then that would appear somewhere in your cloud, and then from your machines, your virtual machines, you could just log into that NFS or CIFS share. I wasn't able to get it working. I'm really excited about this project because if you saw my talk earlier, I'm kind of an NFS person, and like while you can share storage between virtual machines in an OpenStack cloud by creating Cinder block devices and putting file systems on that, it's unwieldy to try to take that file system, unmount it, eject the block device, attach the block device somewhere else, and then mount the file system, discover the file system, and mount the file system. A shared mutable NFS that would just let you pretend it's the 1990s and you're running web hosting would actually be, I think, a pretty big win. And in theory, that shouldn't be very hard to build, and yet Manila struggles. Barbican is a REST API for certificate and secrets. So basically, I have a buddy who does a lot of web hosting on Amazon, and they can get a lot of things from Amazon. But one of when their customer says, hey, I'd like to have SSL, they have to call up DigiCert or email DigiCert and get DigiCert to issue the certificate. Same with CA systems, same with Symantec. And so what Barbican allows you to do is basically put an API that then has multiple backends, and that has a DigiCert backend, and it has a Symantec backend, and it has a dog tag backend. So that you have one unified API where you say, I would like to have a certificate for this website, attributes, and then it would get it up for you. There's a couple problems with it. Like, obviously, Let's Encrypt makes that a lot less interesting than it was a couple years ago, because Let's Encrypt sort of allows you to sort of one-stop shop that anyways. It has an interesting relationship with Keystone. So Keystone is the identity provider for OpenStack, right? And so everything else that you test, when you run the tests or you want to stand it up, everything requires Keystone except Keystone. But interestingly enough, we've kind of gotten to a weird space where the more advanced features of Keystone don't belong in Keystone anymore. They belong in Barbican. So it's like, in order to test Keystone, you need Barbican. But in order to test Barbican, you need Keystone. And so it's sort of upsetting the nice dependency graph that we had before. Their API is also kind of not great. It's actually kind of one of those, here's some JSON APIs. So you fill in fields like meta and values instead of kind of a nice structured JSON blob that would be consistent. So again, it's leaking the and then the reason for that is because it's leaking the implementation on the back end. If you ultimately want to talk to a dog tag CA service, or you'd like to touch to Digitech, you have to provide different values, and Barbican doesn't help you with that at all, which is kind of its one job. So I don't really know what the plan is there. There've been presentations on it going back to Grizzly, which is 2.5, 3 years ago. And it's still considered pretty young, not necessarily it's still in development, and it probably is not really ready for use yet, which is unfortunate.
I thought the team behind that really is not doing it anymore.
Yeah, I have not seen a lot of. We'll see what happens. We'll see what happens in Austin. Yeah, we'll see if there's Barbican meetings.
I've heard it's effectively a dead project from what I've heard.
Oh yeah, so. We definitely kicked the tires on it in Paris, and it was a nightmare to do anything with. Like, these people, I was just like, what are you doing? And I know one of my team members tried to work with them and found some serious derp and noped out. So what their actual status is right now remains to be seen. There's another concept of Barbican, which is that it can encrypt something for you and hold on to it, and then you can get that encrypted thing back or delegate secrets to virtual machines. I've never really understood how they plan to do that. All right, Designate. This thing actually works. So HP Cloud, when HP Cloud was online, Designate was a part of it. And Designate was good. I use Designate all the time for all my virtual machines. It is really nice to be able to boot a machine with one line in a script, and then the next line you set up a DNS record. And the API, or the command line for Designate looks more or less like you'd expect it to, where it's just like designate, record, add, IP address, data. It depends on you pointing your NS records at the right place, obviously. But after that, it just kind of rolls with it. VexHost is an OpenStack public cloud in Canada, I believe, and they have Designate deployed. So you can actually kick the tires on this today if you wanted to. And Designate is implemented as a proxy, kind of like most other OpenStack services, where the idea, HP Cloud implementation was that you would submit records to Designate, to HP Cloud's Designate, and then it would run some things, and then it would basically just set those records that you set up in Akamai's public DNS. And that way HP Cloud or whoever's running the OpenStack is not actually not responsible for running a massive globally distributed DNS, because that's hard to do and not OpenStack's job. So it pushes that information or that responsibility onto someone else. But you have a centralized API on the front end for your users, so you could switch out your backends and they would never know. One of the annoying things about using Designate is you have to provide this DNS domain ID to every request. So this is kind of the classic Designate command. This is actually just list the records that I've set, but you have to specify where the endpoint is, and you have to specify this domain ID at the end of every command, which is super annoying. I'm hopeful that when Designate DNS gets rolled into the OpenStack client, that OpenStack command, that this will become less stupid. But basically, the domain ID just as maps like whatever domain you're set. So I used to have nibblizer.com or cloud.nibblizer.com associated with that UDU ID. And so there isn't a command to just recursively go through and, I mean, you could write a script to do it, but there isn't a command that's like dump all records that I've ever set. Magnum is an interesting project. So Magnum is basically, like in all honesty, I don't know, but it's like containers on Openstack. And so it has this weird concept of bays, and really they don't want to deploy individual Docker containers with Magnum. Individual Docker containers can be deployed by Nova, but like kind of like what Lance was saying at the end of the conversation at his talk, deploying one, like starting one Docker container with an OpenStack API is a needless abstraction. That didn't need to happen, and it isn't a good mapping. But what Magnum lets you do is basically say, Magnum, please create me a Kubernetes cluster. They call them container orchestration engines. So they have one for Docker Swarm and one for Kubernetes, and probably one for Mesos. I don't know. And so you basically say, Magnum, please boot me a container engine. They call them bays. Boot me a bay with the container engine Kubernetes and 15 nodes or something like that. And it's like, okay. And it relies on OpenStack Heat. So Heat, if you're familiar with Amazon CloudFormation, Heat is basically high-level commands abstracted. So you can say, OpenStack, please do several things in sequence and keep doing them until they succeed. And in that way, you can, with one command to Heat, do the equivalent of something that would be a pretty long Ansible playbook. You know, create a network, put some security groups on the network, put several virtual machines in the network, open up the security groups on those virtual machines to map the one on the network, and then associate some floating IPs, and you know, that's the kind of thing you would ask Heat to do. So you say something kind of like this, you're like Magnum bay create name KS bay model Kubernetes. And what you get out of that when this runs, I mean, like certainly it didn't run on my machine because I couldn't get Magnum to work. But the idea is that it will emit Kubernetes credentials, so that then you can immediately start using that Kubernetes to run things, which is kind of, I think, pretty cool. Okay, so how did our Devstack is still Devstacking? This is fine. This is basically expected. It's kind of what it does. So. Does anybody have any questions so far? Okay. So if you want to look at how many hypervisors you have, you can use this hypervisor list. So it's kind of an operator command. And Lance and I were kind of poking at it, and what we found out is that it's basically this. It's basically the same thing on the database side, which is kind of sweet. So you can kind of just like show tables inside your Nova MySQL database, and one of these is. Is it nodes? Compute nodes.
Oh yeah, compute nodes.
I can just paste it. It's okay. And so you can see that has like basically a one-to-one mapping with the Nova show hypervisors that we looked at. You can also poke around in here in the instances. So
It's just instances.
Is it instances? I don't have a very interesting OpenStack. I have one thing in it. I think we can just copy that out. And I have a couple nodes. You can tell I don't have the most interesting names, but yeah, you can't even really see it. But we'll just run some more. And so you can get this stuff out of the database. And there's plenty of times where your OpenStack will kind of wedge itself, and you have to come into the Nova database. But it's actually relatively safe to go into the Nova database and set the real world to be what's in the Nova database. And then OpenStack goes back to being happy. Lance, did you ever fix your broken hypervisor?
I haven't had a chance to complete it.
Okay. Sometimes Nova is famously bad at screwing up host names. So like if you change the host name on your server, on your compute host, you'll end up with two hypervisors, neither of which can boot virtual machines. It's pretty fail.
Or reusing host names for a new server does not make OpenStack happy.
No. You had your chance at server 1. Server 2 now. So if you RabbitMQ list queues, or I think that's a rabbit. So Openstack is basically an application with a message queue and a database. It's that style. Whatever you want to, something, that book with the patterns in open source software. So you can kind of list queues. And so one of the cool things about that is you have this like compute OSAT 00. So OSAT is just the name of the node. And so this is the queue associated with tasks that have to happen on this machine. And so what we can do, oh, this is the open, oh, no, oh, no, maybe not. Maybe we're not doing that. Now we are, here we are, okay. So, how did our, okay. So ps-ef grub compute, and so we can kill we can kill this I don't know why there's two of them. I guess because security group or that's like SG is like run as group. It's like new group, but you get to run it. So what we're going to kill is we're going to kill the Nova compute process, which is fine because we don't really need it anyways. And we're going to be, so this was another Devstack machine. And so when we sue into stack, the way Devstack works is it basically has a screen, and the screen has all of these different windows. And so you can't see it at the bottom because that would be useful. There's all these windows at the bottom. Are people more or less familiar with GNU screen? So it starts with this GNU screen. And so basically, because I killed that command, we can just up arrow and we can see how Nova Compute was running. So we can just turn Nova Compute back on by pressing this up arrow. And then we can come through and control C it. And the reason we control C it is so that we can come here in the web UI and we can just like delete this machine. Whoa, shut off instance. Wait, no, I just want to delete it. That's kind of weird. Why is it? Oh, there it is. And so now, with the list queues, I think is, well, it managed to beat me. It should have not deleted it. Oh well. So what you can do is you can, with RabbitMQ CTL, you can just RabbitMQ admin. I don't know if people have a lot of RabbitMQ. I didn't know this. So if you RabbitMQ admin, you can dump the queue with list queues, and then you can grab the top. And so unfortunately there's nothing in that queue, even though we were trying to preserve it. And so you can grab the actual job task that went down that queue. And so you can pull it out, put it in a file, and it's kind of this JSON in JSON in JSON blob. But you can go through it for a while, and eventually what you'll find after a couple greps is you'll find this like task state deleting, and that'll help you maybe not necessarily do anything, but it will, at least for me, it gained a certain understanding of where things go and how to sort of debug them. And it's worth noting that it's pretty safe to turn off Nova Compute, which is really the thing on your hypervisor that's scheduling stuff. It's pretty safe to turn that off, turn it back on, restart it, kick it a couple times. It won't affect your virtual machines that are running, and it's pretty good at understanding the state of the system when it comes back online. Okay, so I'll get on my soapbox a little bit. One of the big problems that happens when you're trying to boot a virtual machine on a new cloud a new OpenStack setup that you've never dealt with, whether it's a public cloud or Gary set it up or whatever, is that you need to say boot me a size, and you need to say the image you want to start with, and you need to say what network to attach it to in many cases. And part of the problem there is that different clouds will load up Ubuntu. We'll put Ubuntu server 1404 as different names, and so you have to do a lot of like listing and checking before you find the one, and it's hard to programmatically determine which thing is actually Ubuntu trusty. So one of the things I'd like to do is to develop and head towards a standard where we have some standard network names, we have some standard flavor names, and we have some standard image names. Flavors returns to the size of the image, or the size of the machine, like how many CPUs and RAM it has. So if we standardized on something and just picked a standard like prefix, OS standard or something, and then and then the nomenclature came from some kind of an outside body, then all the clouds can make that, and it'd be easier for users that want to use them. So this is kind of my example. You could just have standard Ubuntu 1404, flavor standard small one. Okay, so you might wonder why I have the weird plasma ball. The reason I have the weird plasma ball is because I would like to show off something called Ironic Bifrost. So Ironic started out its life as a driver for Nova. So a driver for Nova, a good example, of course, is the KVM driver for Nova, or the VMware driver for Nova. Something that allows you to create servers, or it allows Nova to create servers when you ask it to. And it started out as the bare metal driver. So it's ironic because iron or something. It's a laugher. And then it kind of spun out of its own project, and it was realized that there's actually a lot of value to bare metal provisioning, even if you don't have OpenStack. So Bifrost was written, which is a set of Ansible playbooks that make it easier to install and run Ironic. All right. So the cute thing so what are we doing here? So the plasma ball is actually, okay. So this is an Intel NUC. Thanks Intel for making the NUC. The NUC is kind of cute. It has something called AMT, which is I think active management technology or something. And then that got wrapped up into a marketing thing called vPro. Some version number. But the point is that it has out-of-band management basically on this little desktop PC. And it's very much similar to how the Dells work, right? Where it's like it has primary network interface, and then there's also a second MAC address on that interface that is the out-of-band management. And so after you get it, you kind of go in to the BIOS setting like you would any other time you were setting up some kind of ILO. You type in a very insecure password that's the same on all of the machines that come out. Yes, it's enabled by default. This is horrible security. Your laptop probably has it if it's a Lenovo. And then you set a password, and then you set like an IP address, and then that machine will answer on those IP addresses. So one of the things we can do, and so what I've done is actually a little complicated, but so I've added, so there's an Ethernet cable running between my laptop and my NUC, and I have a virtual machine on my laptop called Bifrost, and then the Ethernet is bridged onto the same that the Bifrost VM is on. So they can all, the practical upshot of which means that they can see each other. So if we ifconfig eth1, we could ping this 10.1.1.15. That's the actual NUC. And so we can actually AMT tool, this is kind of sweet. You just say power down, and well, I'll put it up here where you can actually see it. You press yes, and you can see the ball turns off immediately. So the ball is actually just a little USB gizmo that HP gave us, that it's like when there's power to the computer through the USB port, it's just an indicator of the power state of the NUC, because it's kind of hard to see the little light when you're all back there. And we can power it back up, and it comes right back online. And so what Ironic was able to do is Ironic is also, like everything else in OpenStack, just drivers all the way down. Ironic has a driver for this Intel AMT stuff that we're using. And so what we can do is we can export a couple variables. These are important because basically Ironic uses a MySQL database, but it drives the MySQL database from a JSON file that describes all your machines and their MAC addresses and such. it needs to know what the local, what the URL of the ironic Python daemon is. And then you need to set an open source auth token to like any random string. And that will encourage ironic to not try to use Keystone, because originally you're supposed to need Keystone with ironic, but we cheated, and now we don't need it anymore, which is fine, because nobody wants to run that for something as trivial as booting a NUC. And so with that, now we can issue an ironic node list, and you get kind of one of these tables, and I call it NUC go go go, and its power state is none, active true. And what we can do is we can basically take that that UUID, we can set provision state to deleted. And so now we can tell that the machine is down. I don't know if you're paying attention, but the light turned off. And we're in state deleting. And so that means, without further ado, that we can deploy dynamic. And so I'm just going to run this command. It just runs Ansible, so it's not as exciting. So I'm going to switch the audio or the video feed over to the NUC, which is off. And oh, crap. Totally know what I'm doing, folks. And so it should go ahead and come off. So the ironic architecture is actually pretty slick. So what it does is it is a DHCP server. It uses DNS mask, and then uses the AMT tool that's like, hey, you need to reboot in Pixie, and it gives it a very specific, targeted at the MAC address of the machine. So we got the ball on. So it should be coming up. It Pixies up, and then it ships it kind of a micro deployer image. It's actually based on CoreOS, and it's just enough Linux that runs ironic node agent.py, which is just a little Python script that then connects, it comes up and it's just a little stem cell. It's like, what should I be doing? Okay. And it connects up to the Bifrost and says, all right, what operating system should I put on this? Do I need to do anything fancy with the RAID controller, blah, blah, blah. Actually copies over the file that is the golden image and DDs that directly onto the hard drive, and then reboots. And by that time, Bifrost has removed the special Pixie settings that caused it to deploy or to boot into the provisioning agent, and it goes nuts. So somewhere in here, I apologize, it's so spassy, but we should see some. Yeah, here we go. Ironic Python agent, something hardware, generic hardware manager. It looks like it's getting its NTP going, or DNS, I guess. And so yeah, and then it'll reboot. At some point it'll start talking about how it's copying files, and then it will reboot the machine, and it will come on up. Are there any questions on ironic and Bifrost? Okay. So the image that you're actually using as a kind of a golden image that you load onto the machine, that image is constructed using something called Disk Image Builder, which is another Openstack project. They kind of built that on their way to do some other stuff. And Disk Image Builder sits at the same layer as like Packer, and it's mostly implemented in Bash and Python. So you kind of just say, build me an image, VM, Ubuntu, and then space, and then just kind of space separated, you add other elements. So you might say, and I need it to have Nagios checks. And you can do it kind of like Puppet classes. You just kind of add the Puppet classes, in this case disk image elements, to your build, and it uses that to build the image with whatever you needed to add. Maybe you had dev tools. Maybe you wanted a local development user. Maybe you wanted, I don't know, Openstack. It's a demo, so it's almost certainly going to fail. Yeah. I don't know. I don't have a keyboard, so I don't really have a lot of debugging facilities. It is kind of weird that it says sleeping. Meh. Okay. Are there any questions? That's all my prepared talks or notes. Okay. Well, thanks for having me. I'll be around for the rest of the day. If you have any other questions about OpenStack, or you'd like to talk about maybe how it is a good use for you, I'd be happy to talk to you. Thanks.
seen a Nook. I wasn't sure how big they actually are.
They're pretty small.
Yeah, it is. That's easy to transport.
Yeah, ish. You know, it's enough that it can come on the conference tour.
Right.